Okay, this is lesson 5.7. This should be pretty quick and fairly simple. This lesson is on scatter plots and trend lines. And as you can see, you will need a ruler and your notebook, and you need to get your notebook ready with Cornell notes. So your Cornell notes, remember, look like this. In the upper left-hand corner, you can write lesson 5.7. Scatter plots. You can abbreviate that. Here is where you will write the essential question, and that's based on this learning target. Write the equation of a trend line and use the line to make predictions. At this point, you can stop the recording or pause it and get that set up, and then hit play again when you're ready. Okay, your essential question should have been, how do you? Okay. If you look at these three graphs, and this part you can sketch in your notes, just make a quick sketch of it. Does not have to be accurate or exact. You can just draw a little X and Y axis and put a bunch of dots that look similar to this, just so that you can come up with these three definitions. And here they are. In this first picture, the dots formed by this graph tend to all move in an upward direction. And that means there's a correlation between what the X is, a correlation between what values there are on the X and what values there are on the Y. And so because there's an upward trend, or because they move in an upward direction, you can say that this graph has a positive correlation. So in your notes, this is what you could do. Draw a quick little graph, make that like that, dots like that, and then just write positive correlation. Actually, write out the words, though. I'm just writing quickly so that you can get an idea of what your notes should look like. In the next picture, this one, the dots seemed to trend downward, and they seemed to form a downward line. And so this one is known as a negative correlation because they're moving downward. So on your paper, you should make a picture similar to this and write negative correlation. And then in the last picture, the dots are all over the place, and there's really no trend that you can see. And because there's no trend, there's no correlation positively, no correlation negatively, this has just no correlation. So all of these are examples of what's called a scatter plot. And a scatter plot just means you are plotting points from data that you've gathered. And sometimes the data that you gather makes a perfectly straight line, and sometimes the data is scattered all over. But oftentimes when the data is scattered, like it is in this one, it's scattered in a way that kind of forms a trend. And this one's kind of forming a trend. And so as you look at these green lines that I've drawn, the first green line has a positive correlation because it has a positive slope. And the second green line that I've drawn has a negative correlation because it has a negative slope. And the last graph, really, you can't make any slope out of this one because there's no real trend. So that's why it has no correlation, because there's no slope that you can draw through any of those points. Okay, so how does that translate into your assignment or some of the problems that you're going to see on your assignment? Well, here's the first problem. So in your notes, you can label this Problem 1. And it says this: the table shows the altitude of an airplane and the temperature outside the plane. This big table here, these are all sets of data points. So the first thing you're going to do is graph the points or plot the points on a graph. That's called a scatter plot, because you're plotting points and they may scatter across the graph. So at this point you should stop the video and create a graph and plot each of those points. Make sure that you label the axes, and when you're all done, resume the video and we'll continue on. Okay, so I've plotted the data on this graph. A couple things to notice. In a table, usually the first of the two variables will be the x. So I've labeled the first variable in the table, altitude, as the x and the temperature as the y. And then I put my temperature on the x-axis, my altitude on the x-axis and my temperature on the y-axis. And then I labeled it x and y, altitude and temperature. And then I had to come up with a scale that would fit all of my data. So because I already had a graph that was 10 by 10, I made each of these worth 500. So it goes 500, then 1,000, 1,500, then 2,000. And notice I've only put a label or a number on every other point. So 1,000, 2,000, 3,000, and so on. Same was true on the y-axis. Each of these was worth 10, so it goes 10, 20, 30, 40, but I've only labeled every other one, so 20, 40, 60, 80. And then I will put my points on the graph. Now because I have the scale that I do, and because my numbers are so large, these points are plotted, but they're not 100% accurate, which you can't give me an accurate point unless you've got a scale that goes down to the tenths, and that would be so huge that it would be nearly impossible for me to show you on this presentation. So I've put all the data on one graph, and you can see all the green points. Now some of these points don't make a whole lot of sense. For example, the trend is that the temperature is decreasing, but all of a sudden when you get to 4,000 feet, you'll notice it goes back up to 26.2. And that could just be a hot air pocket where the temperature was taken, or it could just be some other anomaly. But it doesn't really matter, because in this scatter plot you're looking for a trend. And the trend that you should be able to see is that for the most part the temperatures are going down. So what kind of correlation do you have here in this scatter plot? You have a negative correlation. And what does it mean? It means that as the altitude increases, the temperature decreases. So you could even write that. As the altitude increases, the temperature decreases. And that kind of makes sense. The higher you go up in the air, the cooler the temperature is going to be. Okay. Next problem. Very similar. We're going to call this problem 2. But in this problem, you're going to make a scatter plot. And then once you have the scatter plot, we're going to draw in a trend line. So first thing I want you to do at this point is the same thing that you did on the last problem, and that is take this information from the table and create a scatter plot by graphing it in a graph. So you could set up a graph just like you see here on this screen on your paper by making a 10 by 10 x and y axis. Notice that I'm only using quadrant 1. So set that up, plot the points, and then after you hit resume, we will go over the rest of it. Okay, so I've taken the age of a panda and made that my x-axis, and the weight my y-axis. And then I came up with an appropriate scale. So for the age, I just went by ones, 1, 2, 3, 4, 5, 6, 7, and so on, but I only wrote every other number. So what you see is 2, 4, 6, 8, 10. And then for the weight, I had a decent sized graph, so I just made each one worth 5, 5, 10, 15, and so on, but I only wrote every other number. So what you see is 10, 20, 30, 40, and the lines in between are worth 5. and then I plotted the points. Now, if you were careful and you noticed in the table, you noticed that it went 1, 2, 3, 4, 5, 6, and then skipped up to 8, and then skipped to 10, and skipped to 12. And generally that happens. Even to you as you were a child, you probably had checkups very frequently as you were a young person, and then the older you get, the less often you have to have your weight taken or your physical exam. So I've made a scatter plot. That's part A. The next part asks you for approximations. So what you can do is take your ruler and you try to draw a line that fits through the points as best possible. A lot of people will put their ruler down at 0 and connect it with the last point. And sometimes that works. If I do that in this graph, does that line represent the points that are plotted on my scatter plot? Well, it doesn't cross through every single point, and you never will be able to get that. When you draw a line of best fit, what you really want to do is try to fit the line on the graph so that it goes through as many points as possible, or it has the points the same distance from the line. So what I'm trying to do right now is position the line so that it fits. So you can see that it crosses through this point and this point, kind of this point, kind of this point. It has one point below the line and then a couple points that are really close but just slightly above the line. So that's the line I would use to try to draw a trend line for this data, or try to draw a line that fits. And then once you have that line, none of the points now make a difference, because what you're going to look at is the trend line. What does that mean? That means I can take a guess about what a 7-month-old panda might look like. And the way I do that is I move along the x-axis until I get to the number 7, and then I draw straight up until I hit the line. And once I hit the line, I can go straight over, and the number on the y-axis that's represented by where it is on the line is my guess. So looking at this graph, here's 30, here's 35, so a good guess might be 34. If you want to get really tricky, you could say maybe 34.1 or 34.2. But this might be a 34-pound panda at 7 months. When you draw a trend line and you make a guess that's inside of the data, in other words, my data spans from 1 to 12. When you make a guess about data within the numbers that are graphed, that's called interpolation. And the easy way to say it is to guess within. You're guessing within the data. That's why it has this in the front, interpolation. Part C says, what's the approximate weight of a 13-month-old panda? Well, to do that, you really have to take a guess outside of the data, because the last known measurement that you have in your table is at 12 months, and you're going to guess outside of that. So you go out to 13, go all the way up to where it hits the line, and go all the way over, and my graph really doesn't show it very well, but that would be at about 60. So a guess for the approximate weight of a panda that's 13 months old might be 60 pounds. And when you take a guess that's outside of the data, that's called extrapolation. And that's just a guess outside of the data. And really this other definition should say within data. So interpolation is a guess within the data, extrapolation would be a guess outside of the data. And that's problem 2. So pretty much these two examples, problem 1, where you simply plot the data and see if there's a correlation, or problem 2, where you plot the data, try to find a trend line, and then make approximations. You're predicting using the trend line. Those are the only two examples for lesson 5.7. So the assignment, if you choose to get started ahead of time, is lesson 5.7, 7 through 15. Those are the proficient problems, and 19 through 20, those are the exemplary problems. Alright, at this point you should go back, look over your notes, write in some questions in the margin for problem 1 and for problem 2. Once you've written the questions, end the notes with a horizontal line and write a summary. Remember, the summary should answer the essential question, but it should also address each of the questions that you came up with in the margin next to problem 1 and problem 2. And when you get to class tomorrow, I will check over those notes to make sure that you have taken really good notes and at least attempted to summarize your Cornell notes.